class. Today is Monday, February 20th, President's Day. Hope you had a good President's Day today. So this is the week 8 preview. Just a couple things I want to talk about real quick, and then at the end, I want to go into a little bit of detail of something that's coming up in the class. That part of this video will be optional. If you don't want to listen anymore at that point, you will have fulfilled your obligation to watch this video, and I'll make sure that I tell you when that point comes. Anyway, week 8, we got lesson 15, I think, and then maybe it's just 14. Hang on, I guess I better find out. Let's see. Okay, so lesson 14. Okay, that's right. Lesson 14 is the first of the week, and that has a homework quiz and a group meeting quiz. That's just a regular lesson. Lesson 15 just has a group meeting quiz because that's the exam review, and the exam is this coming week. It opens up on Thursday at 12 a.m. So if you're not sure what that means, that's actually that's the midnight between Wednesday and Thursday. So you'll have all day Thursday, all day Friday, and then it closes Saturday at 11 p.m. and that's Mountain Time. So you'll have to adjust that due date for your time zone. Okay. Let me say that again. I think I have to say that differently. If it's 11 p.m. Mountain Time and you're in the East Coast and you're on Eastern Time, I believe that means the test is due at 1 a.m. on Sunday morning for you. But like I said before, please don't look at that and say that it's due Sunday and think you got all day Sunday to work on it. You don't. Okay. So a couple things about the test. First of all, it's a comprehensive test, so please do not forget the stuff that you learned on the last test or that you were asked about on the last test, because that was about half of what we've done so far. So it's reasonable to expect that there might be 30, 40, maybe even 50% of this test that's old stuff. So please don't ignore that. Cheat sheets. The instructions are going to tell you get one side of a sheet of paper for cheat sheet. I am changing that. You get both sides of a sheet of paper for cheat sheet, just so long as one side is this, what's it called? Statistical test flowchart thing that I sent you. I sent you a blank one recently. I've started to fill mine out a little bit. I want to just see what it looks like. You certainly put whatever you want on there. Oh, and by the way, and then on the back side of that sheet, you can put whatever stuff you want. Anyway, just to kind of give you an idea of what my flowchart sort of looks like. So I don't know how well you'll be able to see this, but starting from the left, it talks about, hey, what if you have a quantitative response and you've just got one sample, have two different columns here. The first one is sigma known. Well, if sigma is known, I know that's a z-score, so I'm going to use the z-applet to solve that. And oh, by the way, my null hypothesis is going to look something like mu equals blank, so mu equals something. How do I do confidence intervals? Well, it's going to be x bar plus or minus z star, so that's the z-score associated with whether you want the 95% confidence interval or the 90% confidence interval or the 99% confidence interval. That z star is going to correspond to whatever confidence interval you want. So it's z star times sigma over the square root of n. What else I want to know? Oh, some of the requirements for doing a z-test. I should have simple random sampling. That's what SRS stands for. And x bar should be normal. How do you make sure x bar is normal? Has to do with sample size and has to do with the central limit there. Okay, anyway, next column is sigma. Let's see if I can do this without looking at it. Sigma unknown, so that's a t-test. So I can either use the t-applet or I can just use SPSS and have it spit out all the important information for me. Once I get into SPSS, what do I need to do? Well, I go to Analyze, Compare Means, One Sample t-test. And then over here in this box here, I say, don't forget to put in the test value. Whatever the null hypothesis is, if it's mu equals 18, that's what goes in the test value box, 18. If it's mu equals 55, you put 55 in the test value box. If you don't put anything in the test value box, it's going to assume you're doing mu equals 0 as your null hypothesis. And unless that is the truth, which most likely is not on a one sample t-test, you're going to get the wrong answers because you didn't change that value. How do you do confidence interval for one sample t-test? Well, it's going to be x bar plus t star times s over the square root of n. So very similar to the one sample sigma known test is the one sample sigma unknown test when you're talking about confidence intervals. But instead of a z, you've got a t. That's because z corresponds to sigma known and t corresponds to sigma unknown. And instead of a sigma, in the formula, in the calculation, you've got an S, because you don't know what sigma is, so you can't use the sigma in the formula on the one sample sigma unknown. And then let's see, under the next two columns, so this is two samples now. First one says, hey, are they dependent? If they are, I'm going to use a t-test on the delta column. Is that what I wrote there? T-test, I can't read. It's a paired t-test. I didn't really write it there, but I know it's a t-test on the delta column. If they're independent samples, I'm going to use a two-sample t-test, also in SPSS. Now, if you look in SPSS, there is an option to do the two-sample, I think it says two-sample paired, I believe is what it says. You can use that if you want. The book does not tell you how to do that. I'm not going to show you how to do that. But if you want to figure it out on your own and use it, feel free to do so. One thing I've noticed as I've gone through this class a few times is when I've got a question that's two-sample paired, typically the data come out in two different columns. So you'll have like a before and after score, or a first twin, second twin score. You'll have two columns of data, and what you need to do is you need to create a third column using formulas, and that column will be called like the delta column, for instance. That's what I usually call it. And then you actually do a one sample t-test analysis on the delta column. So even though it's a two sample paired, when you get to SPSS, you're actually doing a one sample t-test analysis on the delta column. I wrote down in here that the null hypothesis, mu sub d equals 0, is always, always, always what the null hypothesis for a paired t-test situation. And then last but not least, I've got the two sample independent. So I'm still going to do a t-test on that, but they're going to be independent samples. And in this case, typically I'll have just one column of data, one column of the numerical data. And then I'll have another column that says group A or group B, or Chicago versus San Antonio, or whatever. Anyway, I've got a column that's got the data, numbers in it. Then I've got a column that's got the indicator that tells me which group that row belongs to. So you have to go in and recode that column. SPSS, being the lovely, powerful tool that it is, doesn't understand how to do a two-sample t-test if your group name is a category, for instance. Okay, if it's ones and twos, it can do it just fine. Anyway, it's a weak program. If you got to lesson 14 already, you know about three samples, you know about ANOVA. Anyway, fill in all this stuff with things you want to remember about these different situations, because I'm telling you right now, here on out, that's the most important part of what's going on in this class. We've been feeding you lesson by lesson and say, okay, here's a one sample sigma known, here's how you do it. Next lesson, so here's a one sample sigma unknown, here's how you do that. Then there's a two sample paired, here's how you do that. Then there's a two sample independent, here's how you do that. Lesson 14 is a three or more samples. Obviously, they're not going to be paired. There's a sort of pairing that goes along with three or more samples, but it's beyond the scope of this class, so we're not going to talk about it. So basically, this is three samples independent, and it'll show you how to do that. And then over on this right-hand side, we've got four more columns. Three of them are for categorical response variables, and that'll be all of the stuff before the next test. And then the very last column out here is when I've got two quantitative response variables. I'm telling you, from here on out, this class is about, can you identify which of these columns I'm going to be using on a particular problem? So anyway, that's kind of what you should do for your getting ready for the test. Okay, now, we had a question on the homework quiz for lesson 12, I believe it was. Let me share it. You may remember this. I think it is right here. Okay, you remember this question? The mean salary of NBA players in 1996 was $3 million. You are interested to know if the mean salary of NBA players increased between 1996 and 2006. My first reaction to that question is, duh, of course they did. A simple random sample of 90 professional basketball players' salaries in 2006 was recorded. Then the data are found in NBAsalaries.save. This is an SPSS data file. And then it asks you, hey, what kind of a test is this? I'm telling you right now, we're going to be asking that a lot from here on out. Each test is going to have anywhere from 2 to 3 to 6 or 7 of these kinds of questions on the test. And it's an area where a lot of students really, really struggle, partially because we don't do a very good job of giving you enough examples of how to do that kind of stuff. And frankly, we don't really go through, there is a technique on how to do it. Really, the best way to get good at doing that is to just do a lot of them. But there's also a technique, and I'm going to tell you about how to do that. Okay, you're now to the point of the video where if you're tired of listening to me and you want to be done, you have met your obligation to watch this week's announcements video. However, if you want to get good at what I'm talking about here, you might want to listen for the next few minutes. I'm going to do a few examples, so it's going to take a little bit of time, but I think it'll be well worth your time. All right. I'm going to get back to this question in just a minute. But there is something I want to tell you. I'm also going to email you and post with this video these research scenarios for biostatistics. So a few years ago, a couple of years ago, I really got frustrated that this concept was not taught very well in the class. So I came up with a whole bunch of scenarios to help you guys to get good at this if you wanted to take the time to put into practice. So here's how this is set up. You'll notice these are labeled A1 through A8. Then there's a page break, and then there's B1 through B8. And then there's a page break, and so forth and so forth. I've got A, B, C, D, E, F. I think I've got 6. Let's go all the way to the bottom and find out. 6 different groups of 8 scenarios each. A, B, C, D, E, F, yes. 6 times 8 is 48. So I did 48 of these scenarios. I put them into groups of 8 on purpose. That's because each group of 8 has one of each of the following 8 scenarios. You've got one sample okay, so for the quantitative responses, you've got one sample sigma known. You've got one sample sigma unknown. You've got 2 samples paired. You've got 2 samples independent. And then you've got 3 or more samples. So that's 5 of the 8 different types of scenarios. The other 3 are for categorical response variables. We haven't talked about those yet, but we will very soon. Anyway, there's categorical 1 proportion, there's categorical 2 proportions, and there's categorical, it's really not 3 proportions, but it's like 2 by 2 type or bigger type of scenario there. And that'll make more sense as we go on. So if you're thinking, well, I really can't work on these because I don't know all 8 types yet. Well, you can. If you hit one that's categorical, just say that's categorical and put it off to the side and look at it in a couple of weeks when we've done some more of that stuff. So this is not required. You don't have to do this. And I have the answers. I'm not going to give you the answers, but what I will do is if you decide, hey, I'm going to tackle the A scenarios here. So if you were to do that right now, you could answer 5 of them, and 3 of them you wouldn't be able to answer because they're categorical, but the other 5 will be 1 sample sigma known, 1 sample sigma unknown, 2 samples paired, 2 samples independent, or 3 or more samples. Those are the 5 different kinds they will be. So you go through here and you say, okay, I think this one is 2 sample paired. I think this one is 1 sample sigma known, and so forth and so forth. And you email that to me, and then I will email you the answers, if you will, to those 8 situations that you've evaluated with full explanation. So it'll be like, here's the answer key. These are the answers, and here's also the answer key. Okay, I'm going to show you how this is done. Everybody's got a different way to do it. This is how I do it. So there are several questions you need to ask yourself when you're trying to determine what sort of a situation or a scenario you have. First thing you need to do, what is the experimental unit? We haven't talked a lot about experimental unit yet. So let me try and explain that here in just a second. I guess I'll blow this up, make it bigger. Okay, what is the experimental unit? Second question, what is the response variable? Third question, is the response variable quantitative or categorical? Fourth question, how many samples are there? So if you've got a quantitative response variable, you've got 1 sample. The next question you say is sigma known. Or if you've got 2 samples, you say, are they paired or independent? Or if you've got 3 or more samples, no more questions need to be asked. You just know it's ain't over there. If it's a categorical response variable and you're looking for 1 proportion, you're trying to test 1 proportion, well, that's something. If you're trying to test 2 proportions, that's something else. Or if you've got multiple rows and or columns, that's a third thing entirely. So really, these are, if you take this approach on every single one of these things, you will get better at solving them. Okay, one more thing I want to tell you is The scenarios that I created, I've purposely made them kind of hard. So if you can get good at those, the ones that come up on the test, should be no sweat for you. All right. So let's go and look at the first scenario. So back to the salaries of the NBA players. Okay, the first question says, what is the experimental unit? We haven't really talked about what an experimental unit is. An experimental unit is the smallest entity. That could be a person, could be a thing, could be a place, could be a measurement, could be anything, where I will be collecting one single piece of data. Okay, so let me say that again. Smallest entity from which I will collect one piece of information or data. That's the word unit. When you talk about experimental unit, that's kind of what it implies. What is the thing from which you're going to get one piece of data? All right, so we've got NBA players. We've got their salaries. We know that in 1996 they were $3 million. So we're interested to know if the mean salary of the players increased between 96 and 2006. So we've taken a simple random sample of 90 professional basketball players in the year 2006 and recorded them. Okay, what is my experimental unit? Well, we're talking about salaries. So I'm thinking here my experimental unit would be a single NBA basketball player in the year 2006, because I'm going to collect a salary from that single person. So that's my experimental unit, a single player. And then the response variable, let me page up here so we can go back to the questions. The response variable is just basically saying what are the data, what is the bit of data, the piece of data I'm going to collect from that experimental unit. In this case, the response is a single salary. All right. So third question is that response variable quantitative or categorical? Well, it's a number, so it's possibly quantitative, and it does represent a continuum, if you will. It's not a category that's a number. It's just a number, and you can add them and subtract them. You can do math on them, so that makes sense. So it sounds like it's quantitative to me. Now, how many samples are there? Well, let's see. We're talking about players in 96, and we're talking about players in 2006. So I might think there's 2 samples here, but there's really not, because I haven't really said anything about collecting information from some individual players in 1996. I just come out right at the start and I say the mean salary in 1996 was $3 million. So there's really only one sample, and that's players in the year 2006. So if there's one sample, I want to know, is sigma known or not? Well, it doesn't explicitly say what sigma is, so I'm going to assume that sigma is not known. What should I need? It's quantitative. It's one sample. Sigma is not known. This is a t-test. It's a one sample t-test. Okay, let's try another one. Okay, so these next two are A1 and A3 out of those first 8 that I just showed you a minute ago. All right, and like I said, I've tried to make these a little bit hard, so try and follow me through this. Cyrus has the job of quality control for a local grocery chain called Food Giant. His sister Melanie has the same job for a competing chain, which is called Megamart. Cyrus claims that Food Giant gets better delivery times than Megamart on deliveries from Mills Foods on their dry good products. So that's all interesting information so far, but none of it has anything to do with what's important. All right, so Cyrus and Melanie each select 45 deliveries from Mills Foods to their respective stores over the past 6 months and determine the time from order placement to delivery receipt. They want to compare the average delivery times. What hypothesis test should they use? Okay, so what is the experimental unit? Well, let's think about this. Okay, so I can see in here they're talking about delivery times. So it feels like delivery times has something to do with the response variable. And I want to figure out what is the smallest entity from which I'm going to extract a single delivery time. And that would have to be one delivery of dry goods products. So the experimental unit here is a single delivery of dry goods products to either Megamart or Mills Foods. Okay, so now that we know what the experimental unit is, we need to figure out what the response variable is. We've kind of talked about it. It's sort of hard to talk about those two things independent of each other. You kind of have to figure them out at the same time. But the experimental unit, the response variable seems to be the delivery time. And then is it quantitative or categorical? Well, it's quantitative because it's a number and you can do math on it. You can calculate the average delivery time. So since you can do math on it, it's a quantitative variable. So the fourth question is, how many samples are there? look through this again. Cyrus claims that Food Giant gets better delivery times than Megamart. So Cyrus and Melanie each select 45 deliveries from Mills Foods to their respective stores over the past 6 months, and then determine the time from the order placement to delivery receipt. So it looks to me like there's two samples. There's a sample of size 45. I'm sorry, let's see. Each like 40. Yeah, okay. A sample of size 45 of deliveries going to Food Giant, and there's a sample of size 45 of deliveries going to Megamart. So it looks like there's two samples. Are these paired or are they independent? Is there something about, so let's suppose Cyrus is randomly selecting deliveries, and he selects the delivery that was ordered on Tuesday, the third Tuesday in December 2016. That was one of the deliveries he randomly selected. Did picking that delivery force Melanie to pick a corresponding delivery that had some similarity between that delivery that was being delivered to Cyrus? And the answer is no. They didn't do anything like, hey, let's make sure they're on the same day, or let's make sure it's the same driver, or let's make sure it's the same person that took the order, or whatever. They didn't do any of that. They're just randomly selecting 45 deliveries from each of these two different piles of numbers. Okay, there's no dependence at all. So these are independent. We've got two samples. They're quantitative response variables. This is a two-sample t-test, two-sample independence t-test. All right, let's do one more. Sylvia is a medical researcher. She wants to study the metabolism rates of caffeine in men and women. Sylvia decides to use couples for her comparison and devises a study where both spouses of a couple will eat the same foods because she believes that diet has a significant effect on metabolism rates. She tries to pick couples where the general health of both spouses are similar. The study requires blood to be drawn after consuming caffeine in similar amounts, adjusted for body mass. She has 37 couples in her study and wants to determine if the amount of caffeine in the blood is different between men and women. 40 minutes after consuming the caffeine, she takes a blood sample from both the husband and the wife and measures the caffeine still in the system. What hypothesis test should Sylvia use? Okay, let's talk about experimental unit. Ultimately, she's going to be taking blood samples, and she's going to measure the amount of caffeine still in the system. So it would sound like she would probably take a blood sample from everybody in the study. So the experimental unit here is each individual man or woman in the study. So and the experimental unit more specifically is a single man or a single woman in the study. What is the response variable? Well, the response variable is going to be the amount of caffeine still in their system after 40 minutes. So she's probably got some scientific way of measuring how much caffeine, some chemical titration method or something. I don't know exactly how you would do that. Maybe run it through a mass spec or something. I don't know. But anyway, so she's going to measure the amount of caffeine still in the system. So it's the response variable is quantitative again. Now I have to decide how many samples she's got. Well, she's got 37 couples. So is that one sample of 37 couples? Well, not really, because she's trying to tell the difference between the men and the women. And she did sample the men and she did sample the women. So she's got two different samples, men and the women. Are they dependent or are they independent? So in other words, if she picks Rex to be in this sample, does that automatically, Rex is married to a woman named Pam, does that automatically pick Pam to be in the study also? And the answer is yes, because she specifically wanted to do that. She wanted to study the difference in spouses because she wanted their diets to be the same and their health to be generally the same. So she's not just going out in the medical records and randomly picking 37 men and then picking some other 37 women. She's picking people that have some sort of a connection so she can make that determination between the couples. So this is a paired sample situation. So we've got quantitative response variable. We've got two samples. The data are paired. Therefore, this is a two-sample paired t-test. So what would she do? She would collect the data, and then she would come up with some sort of a delta or a difference between the couples. You know, maybe the husband still has 8 micrograms per deciliter in his blood still, and the wife has 6.5 micrograms per deciliter in her blood. So that would come up with a difference of 1.5 deciliters per microgram, and then she would do an analysis on that difference column rather than do an analysis on the men versus the women. Take the difference of those two, do a single sample t-test analysis on that. But even though that's how you do the analysis, it's still implies that this is a 2-sample test. Okay, hopefully that wasn't too intimidating for you and gave you an idea of what sorts of things you should be looking for as you're doing these scenarios. So that's it. Study hard, pray hard, get ready for your test. Got questions about concepts or anything like that, give me a call or give Kristen a call. There's also the tutoring center. If you want to send me a text or send me an email, that's great too. Just let me help you with things that are confusing to you or hard to understand. All right, have a great week and good luck on your exam, and don't be strangers. Thanks. Bye.